Today we will understand linear equations. Okay, so linear differential equations, how we will find the solution to the linear differential equation. So firstly, let's see what are linear differential equations. So linear differential equation, the way we define is the highest order derivative is a linear function of lower order derivatives. Okay, so if I define first order linear equation, first order linear equation. Okay, so first order linear equation may in first order linear differential equation, highest order of derivative would be dy by dx, right? So it should be a function of linear function of what? Lower order derivative, and lower order derivative would be y, right? So px into y plus qx. Okay, similarly if you define second order linear equation or linear differential equation, so in second order linear differential equation, the highest order differential the derivative term would be d2y by dx square, okay, is equal to it. So highest order derivative should be a linear function of lower order derivatives. So dy by dx into px, hang on, I should write it properly. So px dy by dx. So lower order than first order would be y, that we can choose qx into y plus some other function. Okay, so this is how you define first order linear equation, second order linear equation, right? So in all these, the highest order derivative are linear function of lower order derivatives. Okay, so do you notice one thing? The coefficients of these dependent variable or derivatives are function of only x, function of only x. Okay, here also, here also, here also, right? Here. So in this video we will cover only first order derivative. So I will try to derive how we achieve to the solution to these kind of differential equation. So in my previous videos I have talked about integrating factor, how we calculate integrating factor, how integrating factor helps in finding the solution. Alright, so continuing with that integrating factor, let's try to have that one observation. By the way, in this case, let us write this linear equation properly. Okay, only first order we are considering, so we can erase the rest. Okay, so first order differential equation, you can write dy by dx plus pxy. By the way, let me call it a small p and this let it be small q. Just a way of representation, so that if I take this on the left hand side, I don't have to write minus sign. So this is capital Px and then is equal to capital Qx. Okay, just a way of representation. Okay, now what is integrating factor, by the way? E to the power px. How am I calling this integrating factor is already covered in my previous videos. E to the power px into dx. Okay, so let's have this observation. If I take a derivative of what? This integrating factor into y, what will you get? Can you differentiate it? Of course you can, by the first function and second function rule. So it would be first function into differentiation of second one dy by dx plus second function into differentiation of the first one. So differentiation of the first one would be what? It's like e to the power x. So e to the power x derivative would be e to the power x, but it is a nested function, right? So in nested function you have to differentiate this also, and if you differentiate dy dx of px dx, what will you get? Just px, right? Consider it like this, dx and dx cancels out and derivative of that, or you can consider it inverse of integration. So this is what you get into p. Okay, I'm not writing px, but it is still a function of p. Okay, what do you observe? Take e to the power p dx common. What will you be left with? Dy by dx plus what? P into y. By the way, what is this? Isn't it right hand side of your actual equation? It is, right? So what you can write? Qx in place of this. So basically Qx into e to the power p dx. I'm going to erase this part here, and you can easily integrate this, right? What is written here? Dy dx e to the power p dx integration into y. When you will integrate both sides, what will you get? Dx will go on that side, and here e to the power p dx into y is equal to integration of qx into e to the power p dx into dx plus c. By the way, you don't have to remember this formula. Okay, you should, I would not recommend to memorize that formula. Instead, what you remember is the way this procedure, the way it has worked out, right? So from here you can calculate y, and that would be the solution, right? You can just rewrite it. Y is equal to e to the power minus p dx, and this would be under bracket. That's it. This is your solution to the first order linear differential equation. Okay, if you want to find solution of second order linear differential equation, you have to reduce it to the first order and you follow the same procedure. Okay, so let's take an example and try to do this. Remember that procedure. Okay, you can go back in the video and just recall that procedure. I'm going to take a simple example and I will not use the formula. Okay, formula you don't have to use. Plus 1 by x y is equal to 3x. Okay, just compare with the standard equation. What is the standard equation? Plus px into y is equal to qx. You can have the value of p. P is 1 by x. What is q? 3x. Now what can be the integrating factor? E to the power p dx, and this can be what? Log x, and this is just x. Integrating factor is x. Now remember the procedure. What you did? You took a derivative of what? Y into integrating factor is equal to what you got? Qx into integrating factor. Qx was 3x into integrating factor is x. All you have to do is to remember this procedure and now just integrate. Okay, what will you get if you integrate? You don't have to remember that formula. You just multiply integrating factor with y and take this derivative is equal to qx into x. Okay, now once you will integrate both sides, this equation xy is equal to 3x square dx plus c. So this is what? X cube, right? Plus c. Xy is equal to x cube plus c, or y is equal to x square plus cx to the power minus 1. This is your solution to the first order linear differential equation. Okay, you can comment under the video and say if you don't understand anything, you can ask it. Thank you so much for watching the video. Do subscribe to the channel and you can recommend any topic, any difficulty in engineering mathematics. I will cover that topic anywhere, whether in any semester you are. Okay, I will try to cover a video on that topic. Thank you.